Okay. Hello, everyone. Thank you for joining my talk today. So let me start with a question. How many of you get really excited when you see the following message? Change is requested. Not exactly the kind of notification that you would take lightly, right? You're working on a challenging ticket, you finish the changes, you open the pull request, and then you probably move to some other ticket. And a few days later, a reviewer is asking you to rewrite the whole architecture. By that point, you have already switched context. There might be even merge conflicts that you have to fix now. This is not a productive situation, right? It's something that is slowing us down. And I think we have all been there. This is not a new problem. Let me tell you this. There is a better way to do this. Before we proceed, let me quickly introduce myself. My name is Stelios. I'm a staff engineer at Perry Street Software. We are the publisher of two of the world's most popular LGBTQ+ dating apps, Scruff and Jacked, which currently serve more than 30 million members worldwide. My first Android app was on Android Gingerbread, so you can safely say that I've been working with Android for more than a decade now. I'm deeply passionate about architecture and testing, always trying to find ways to keep our code base healthy, maintainable, and consistent. And my talk today touches both of those areas. If you have any questions, feel free to reach out to me on Twitter or LinkedIn, or just come find me right after this talk. And don't worry about taking photos of the slides, because every code sample that you'll need from today's session and all the links will be shared with you at the end, including the slide deck. So sit back, relax, and enjoy the talk. Okay, let's start with some code review comments. These are comments that you might be already familiar with, or comments that you might encounter in the future. The view model shouldn't interact directly with the repository. It's best to communicate with a use case instead. Didn't we recently agree that use cases should only expose a single public function? Hey, it looks like this repository is not placed in the correct module. Wait, I'm confused. Are we supposed to access string resources directly from view models? Do you know what these comments have in common? They are all code review smells. And yes, just as we have code smells, we can also have code review smells. Let's take a look at the first comment. Why shouldn't the view model communicate directly with the repository layer? Is this a global best practice that I'm not aware of? Is this an internal rule that we have defined? When did we align on this? Moving to the second comment. The reviewer is mad at me because I exposed more than one public function in my use case. Well, I didn't know about that. The project is building, the app is working, so why should I refactor my code now? Third comment. I partly put my repository in the wrong module, right? Well, I don't know where to put it. I just joined this team. I have no idea about the architecture that they're following. And the fourth comment, accessing string resources in view models. Well, I want to send a string from my view model back to the view layer as part of the state. So I'm extending the Android view model, I get access to the context, and I can definitely access resources now, right? Nobody's preventing me. Do you notice any pattern here? We are debating architecture and best practices in a code review. This doesn't sound right. I have finished my ticket, and now I'm told to roll everything back. There must be a way to enforce those guidelines early in the process, right? GitHub is not the right place for these types of debates. You will end up with threads cluttered with dozens of comments, which help no one. This is a problem. And to be fair, it's a common one. It is not new. To be even more precise, though, this is a symptom of a much deeper problem. Let's see. No architectural alignment and documentation. This is the real problem. If you're debating architecture in code reviews, you're probably missing a process as a team. There needs to be alignment on the architecture that you will follow as a team before you start working on a new feature. This is the first part of the problem. The second part is about documenting the architecture. If your architecture and best practices are not documented, you should not expect your team members to remember these practices. I'm not supposed to remember why view models should not access resources or why view models should not depend on repositories directly. Because as engineers, we are not designed to remember every detail in the architecture of our code base. But we can build the tool that will do that for us. We're designed to create solutions, right? So we can build an automation that enforces those standards. An automation that enforces us to follow the architecture and the best practices that we have agreed upon as a team. And that is a Lint rule. Lint rules will be the source of truth for our alignment. They will be the written agreements for the architecture of our code base and the established best practices of our team. By the way, when I mention Lint rules, I'm not referring to code styling or formatting. Those Lint rules are necessary as well, but that problem has been solved long ago. So we'll take them for granted. If you ever receive a comment in a pull request about code styling, maybe an extra blank line that you added, or an unused import statement, please do not address that comment. Instead, ask yourself and your team, why don't we have a tool that will do that for us? When you're reviewing code, you do not want to waste your time trying to identify styling issues, right? Just dedicate an hour, integrate detect or KT-Lint in your CI/CD pipeline, and you're done. Problem solved. So I'm not talking about code styling or formatting today. Today, I'm talking about a much more interesting and important problem, the architectural Lint rules. These are the Lint rules that will allow us to have a healthy, maintainable, and consistent code base that will not degrade over time. A code base where every developer will feel confident when working on new features, knowing exactly how to proceed. Because there will be a well-oiled process in place that enforces our standards and does not leave much room for debate. And this process will continuously evolve as we discover new practices. Now, you might wonder, why does this seem like a new problem? How come nobody has talked about this before, at least on Android? Let me show you why. Take a look at this code. Can anyone guess what it's doing? And by the way, in case you're wondering, this is not obfuscated code. It's real code, written in Kotlin by a developer. This code is a custom Lint rule written in an existing linter that enforces use cases to expose only a single public function. It's addressing one of those code review comments that we saw earlier, right? The problem is that nobody can really understand what this code is supposed to do. And that's the reason why developers didn't bother so far writing custom Lint rules. Because this code is hard to write and hard to maintain. And that's why we have all of those code review smells. Because until recently, there was no framework that would give us an API that allows us to write those Lint rules in an easy and maintainable way. And that's where Consist comes in. Consist is a fairly new project based on one key principle. Lint rules are written in the form of unit tests. And this is what makes the big difference here. Most of us are already familiar with writing unit tests, right? That means we can quickly become familiar with writing Lint rules without having to go through the steep learning curve that other linters have. And since the Lint rules are written as unit tests, we can structure them similarly to how we write tests, using the given, when, then format. This approach will make them easier to write and easier to read. For the testing framework, we can use either JUnit or Cotest. And since Cotest has a handy behavior spec with built-in given, when, then functions, we will use that one. Let's take a look at an example. Given all classes in our production code, when there is a view model, then it extends the Android Jetpack view model. This is a Lint rule that enforces all view models to extend the Jetpack view model that Android provides. Very simple to write, very easy to read. And as you can see, this is just a unit test. Our compiler or the testing framework have no idea that this is a Lint rule, because Lint rules in Consist are written as unit tests. This is what makes them so easy to write. Now, let's review this code to understand what it's doing. Given is the setup of our Lint rule. Just like in unit tests, where given is the setup of the test, the same principle applies here. we specify here the classes that the lint rule should apply to. In this example, we want our lint rule to apply in all classes in production, excluding test code. That's what scope from production does. In the one block, we can apply additional filtering. Here, for example, we filter the classes that end with view model because we want to find all view models from the production code that we defined earlier. Then is our assertion, just like in unit tests. Here we assert that the classes we specified in the previous step follow a specific behavior. This is essentially the lint rule. We assert that all view models have a parent named view model, which is the name of the class of the Android Jetpack view model. We can use the raw name of the class using the hasParentWithName function, or we can use the type directly to ensure type safety. This view model class is the class of the Android Jetpack view model. And that was our lint rule. Pretty simple, right? Written in a nice given when then structure, very simple to write, easy to read, easy to maintain. Now, how do we run this lint rule? Remember, this is just a unit test, right? So we can run it the same way we would run any unit test using either Gradle or Android Studio. And it will run on the JVM without requiring an emulator. Let's run it and see what happens. Oops, it failed. It looks like we have two violations. The login view model and the chat view model do not extend the Jetpack view model. So what options do we have? We can either fix these violations by refactoring these view models to extend the Jetpack view model, or if we consider this refactoring to be a significant technical lift that we do not want to tackle right now, what we can do instead is add these two view models to the baseline. The baseline is essentially a list of classes that we know they're violating this lint rule, and we're okay with that for now, because we do not want to address this technical debt right now. Let's see how we'll do that. We'll create a baseline array with the names of the classes that we want to exclude from this lint rule, and we will use the withoutName function to pass that array as a parameter. Pretty simple, right? Now, what's the benefit of having a baseline? Every code base has its own share of technical debt, right? If we want to enforce an architectural rule or a best practice with a lint rule, even though some existing classes might not conform to it, we should still create the lint rule. Our technical debt should not hold us back. By doing this, we enforce the lint rule in new classes going forward, while also keeping track of classes that will need this refactoring in the future. This allows us to immediately see our technical debt. And it's up to us, of course, to decide when to address it based on our team's priorities. One note here, though. It's not a good sign if your baseline keeps growing. It's fine to add some existing classes that you don't want to refactor right now, but you should not be adding new classes to your baseline, because your new classes going forward should conform to the lint rule. That's why you created the lint rule in the first place, right? And each lint rule would typically have its own baseline. That's why this array is private here. Now, going back to the previous slide, you might notice that there was no error message when the lint rule failed. So when a developer sees this failure in the console, they might not understand what's wrong with these two view models that violate the lint rule. So as a best practice, you should add a helpful error message to each lint rule using the additional message parameter. This will serve as documentation to your team for why this lint rule should be enforced. In our example, the error message could be the following: always extend the Android Jetpack view model to take advantage of its lifecycle awareness and other features it provides. And those are the basics you need to know to start writing lint rules with consist. You have your given when then structure to define the lint rule similarly as you would write a test. You can optionally have a baseline, and you can also provide a helpful error message. Now let's see where consist really shines. It's when we enforce the architecture. It's when we enforce the best practices that we, as a team, have agreed to follow in our code base. This is what will save us from all of those code review smells and the constant back and forth between an author and a reviewer that wastes so much of our developer time. And believe me when I say this, you can write a Lint rule for pretty much anything. Any rule you want to enforce in your code base, there is a way to write a Lint rule for it. The Consist API is rich, flexible, and easy to use. Let's take a look at some examples of Lint rules that enforce the architecture. View models do not depend on repositories. Given all classes in our production code, when there is a view model, again we're filtering the classes that end with view model, then no repository is listed in the constructor parameters. We get all of the constructors, all of their parameters, and we assert that none of them have a type that ends with repository. This is an architectural rule that prevents view models from depending on repositories directly. It ensures a clear separation between our layers, enforcing view models to communicate only with use cases potentially, not repositories. View models do not access resources, another architectural rule. Here we take all files in production, not just the classes, and we'll see why. We filter the files that end with view model, and in our then block, we assert that none of them are importing resources. The reason we use files instead of classes is because import statements reside in files, not in classes. And why do we want to prevent view models from accessing resources? Because this improves the stability. Ideally, your view model should not depend on the Android context at all. Otherwise, you'll have a hard time testing it. Your view model should emit a state, not a resource. It's the view layer's responsibility to derive any resource it needs from that state. Use cases. Use cases consist of our business logic, our domain logic. In an MVVM architecture, view models typically communicate with use cases, which can fetch any data they need from the repository layer, apply some custom logic, and then emit the result back to the view model, right? Each use case is responsible for only one specific aspect of our business logic. That's why it's common for use cases to expose only one public function. So let's see how we can write a Lint rule that enforces this. We start by taking all classes in the production code. We filter the classes that end with use case. Our first assertion ensures that there is no use case that has more than one public function. And our second assertion ensures that the properties of a use case are all private. This way, we strictly confine use cases to expose a single public function, nothing else. Let's see another example for our domain layer. Here, we want to prevent the domain layer from accessing DTOs. As the name indicates, a DTO, or data transfer object, is used exclusively for data transfer. So it definitely does not belong in the domain layer, right? We do not want to pollute our domain layer with responsibilities of the data or the network layer. This aligns with clean architecture and domain-driven design. So we'll take all files in our domain module using the scope from directory function, and we will assert that none of them are importing DTOs. This is another Lint rule that enforces a clear separation of concerns between our layers, between our modules. Lastly, let's see an architectural rule for our repositories. Repositories are located in the repositories module. We start with our given again, which takes all classes in the production code. Our when filters only the repositories, and our then is asserting that all of them reside in the correct module. We don't want repositories to creep into other modules. We want to strictly confine them to their own one. So we saw a lot of examples of custom Lint rules with Consist that enforce our architecture and the best practices that we have agreed to follow with our team. However, there is one more important use case for writing custom lint rules. And that is preventing bugs at an earlier stage. What do we mean by that? Whenever you encounter a bug, it often means that there is a missing test, right? Because your CI/CD pipeline allowed that code to reach your end users. Just as we have tests that ensure that the code behaves as expected and they protect us from bugs, lint rules can do the same. They can protect us against bugs potentially even before the unit tests run, catching issues at an earlier stage of development. Let's see an example. How many of you have used Retrofit? Okay, perfect. For people that haven't used it, Retrofit is one of the most popular networking libraries on Android. Here we have a function that makes a post request with two field parameters, the ID and the name. There is actually a bug in this function. Can anyone guess what it is? And feel free to say it out loud. If we try executing that function, our app will crash with the following error message. Field parameters can only be used with form encoding. What's happening here is that the field annotation in Retrofit sends the data as form URL encoded, and that requires a special annotation on the function itself. The form URL encoded annotation. If this annotation is missing, our app will crash. And this is an interesting example because we cannot write unit tests for our network calls, right? We could write an integration test or an end-to-end test, but these are more expensive and they should not cover the whole code base. So most likely, this bug will not be caught by our CI/CD pipeline. Well, in case you haven't guessed it yet, we can write a lint rule that will protect us from this bug. In all network requests, not just this one. And it will run in milliseconds. It won't be an expensive end-to-end test. Let's see how. Given all functions in the production code, we now take just the functions, not the classes or the files. When there is a function with the post annotation, we filter here the functions that make post requests using Retrofit. And it has at least one field parameter. Here we apply an additional filter to get the functions that have at least one parameter with the field annotation. Then the function should have the form URL encoded annotation. And that was it. In just a few lines of code, we're protecting all of our post requests from the bug that we just saw. Let's see one more example related to dependency injection. Given all classes in our production code, when there is a view model, then it must have the annotation that is required by our dependency injection framework. For example, it should be Hilt view model if we're using Hilt, or Coin view model if we're using Coin. Without this annotation, the app will crash at runtime, but we don't have to worry because this lint rule will catch this issue much earlier. We have now seen lint rules that enforce the architecture and our best practices, and lint rules that protect our code base against bugs. You might be wondering, where exactly should we put these lint rules? What's a recommended project structure? The consist lint rules are just unit tests, right? Which means that you'll need to place them in the test source set of your module. The compiler or the JVM have no idea that these are lint rules. There is no distinction. So you can treat them the same way you treat your unit tests. Let me show you one approach that we recommend. We recommend creating a dedicated module for your consist lint rules. This way you decouple them from the rest of your unit tests, and you have a single place for all your lint rules. In this example, we have our app module, a data module, a design system, a domain module, and we also have our consist module. All lint rules are placed in the test source set of the consist module, the dedicated module that we created. And you can, of course, organize this module as you wish. For example, you could have lint rules for your view models in one package, lint rules for your use cases in another package, and so on. Now, we did all of the hard work to write the lint rules. We placed them in a dedicated module. But there is one step missing, and a very important one. Running our lint rules in our CI/CD pipeline. Typically, whenever we open a pull request, an automated task will run all of our unit tests, right? And if any test fails, we're not allowed to merge that pull request. Well, we can apply the exact same process to our lint rules. Let's see a GitHub action that will do that for us. When a pull request is opened or synchronized, synchronized means that there is a new commit to that branch after we open the pull request. First, we'll check out the repository. Next, we'll set up Java, because we want to run a Gradle task, and Gradle needs a Java runtime environment. Then we'll set up Gradle, and finally, we'll run a Gradle task that executes all tests in the consist module. The task that you see here follows the pattern module name, test. That's how you run unit tests using Gradle in a specific module. If you already have a pipeline that runs your unit tests, you just need this one additional step to run your lint rules as well. If you notice, we added the rerun tasks flag in this Gradle task, and this is necessary when you have a dedicated module for your consist lint rules. Because Gradle might cache the test results and skip executing them the next time because it doesn't know that this module is evaluating code across the whole project, across all modules. That's why this flag is needed. If you're using some other CI/CD system, the setup would be simpler, right? It's just a Gradle task that you need to run. Nothing more than that. So, we've covered how to write custom lint rules using consist. We explored the recommended project structure. And we learned how to automate these lint rules in our CI/CD pipeline. Now let's review all the benefits we get with these lint rules. The most important benefit, you enforce the architecture. There is no questioning, no debate. If there is actually debate in a code review, this likely indicates a missing lint rule. So let's create that lint rule once we align. And going forward, we'll never need that code review comment again. We'll never need to review that particular aspect of the architecture because our lint rules will enforce the architecture. Our lint rules will protect the code base for us. In fact, I would even suggest anytime you're about to request a change in a pull request related to architecture, take a moment and ask yourself, can we write a lint rule? I guarantee you that in most cases, if not all, the answer will be yes. Let's see another very important benefit. Not only we enforce our architecture, our alignment, and our best practices, but we also document them. All of these rules are written down in the code base. They are tracked in our repository. This means we have only one source of truth for our architecture and alignment. Our code, nothing else. And this is the only source that we have to maintain. There's no need for fancy diagrams, wiki pages, articles. Everything is documented within the code itself. Having your code as the documentation is a key principle of extreme programming and domain-driven design. Just as your tests are the documentation of your features, your lint rules will be the documentation of your architecture and the best practices that you have agreed to follow with your team. And as we saw previously, bugs will be caught earlier in the development process. You will be adding a new foundational layer that protects your code base against bugs, alongside the rest of your tests. Essentially, lint rules will make you go faster by protecting your code base from inconsistencies. Whenever there are multiple ways to do the same thing, each developer will likely do it their own way, right? And now nobody knows what's the correct approach. Having strict rules for your architecture and the best practices that you have aligned with your team ensures that there will be only one way to do the same thing. This consistency in your code base will make you go faster. It will increase your productivity because you won't have to think every time how to implement a feature, how to name your classes, where to put your files, how to structure your dependencies, which layers you're allowed to access. Because there will be written documentation on how to do all of that. Everything will be laid out for you. You'll be implementing new features much faster. And code reviews will be faster. There won't be any bottlenecks. And similarly, as you go faster, the same applies for a new engineer that will join your team. Onboarding is not an easy task. We have all been there, right? A new member joining your team might encounter a huge code base with a mix of legacy and new code, and they might feel lost trying to figure out the correct way to implement something. But the Lint rules will guide them. They will be able to understand the architecture and the best practices that you follow as a team just by looking at the Lint rules. I'm sharing here all the links, as I promised at the beginning of my talk. Make sure to take a photo or use the QR code provided to download the slide deck. You will find here a sample Android app with all Lint rules I shared today, including the GitHub action that runs them on every pull request, the official repository of Consist, the official documentation, and the Consist Slack channel where you can chat with the community. And since Consist Lint rules are unit tests, I'm also including a link to the talk that I gave at droidcon London last year about best practices to follow when writing tests. And lastly, my social network links if you want to reach out. Consist is in active development with some cool new features coming soon from the maintainers, so stay tuned. If you're interested in contributing to the project, please visit the Consist repository to learn how to do that. So wrapping up, I'd like you to take away 3 key points from this talk which can be captured in just 3 words. Align, enforce, automate. Align with your team on the architecture and the best practices you want to follow. It always starts with alignment. You cannot write a Lint rule if there is no prior alignment with your team. Enforce the alignment with custom Lint rules and automate them in your CI/CD pipeline. And I will leave you all with a poem. You better write some Lint rules today to automate your problems away. No debates, no code review fights. That will make you sleep much better at night. Thank you all for joining.